We're live.
Hi everybody. Hi everybody. I'm right here like always. Your favorite person is back. So is my dad.
Oh, burn.
What? Did you see that, guys? Wow, that's cool. Yeah. What happened, Daddy? We're okay. Bye, every.
Saying
Wait.
bye.
What? I'm just being silly. I didn't know we're not leaving. Bye, everybody. Bye. Just kidding. But this is not the end. We just started the video. Something's happening. Daddy. Whatever happens, we're going to have to possibly restart. We're back. We're back again. We had to skip it again. That's sickening. Oh, we have to skip it again.
Stop.
We're back again. Alright, nothing. Nothing made it. Hi, everybody. There's our star of summer lessons right there.
That's the board to see. This lesson is going to be called Active Buzzer. In this lesson, you'll learn how to generate a sound with an active buzzer.
Yeah.
Components required: the Eligo Uno 3, which is R3, which is what we see right here. Right there.
It's right there.
We need an active buzzer. We have to look at our parts menu real quick to see what the active buzzer looks like.
Again.
Active and passive buzzer. Same one. Just put it in here.
Buzz. Oh.
Stop. Okay. I hope that's the right one. Okay, just in case. Two jumper wires.
Two jumper wires.
Female
Jump,
to
jump,
male wires. So that's two of these that we haven't used before.
Wait, what?
Two there. Close up shop over here.
So they're connected.
Okay.
You can get this kit at a nice store. Make sure you get this kit. Here, see how that goes? Here.
Okay, so component introduction. Buzzer.
Buzz.
Electronic buzzers are DC powered and equipped with an integrated circuit. They are widely used in computers, printers, photocopiers, alarms, electronic toys, automotive electronic devices, telephones, timers, and other electronic products for voice devices. Buzzers can be categorized as active and passive ones. Turn the pins of two buzzers face up. So we got pins face up. See the pins face up. Okay, pins face up. The one with the green circuit board is a passive buzzer, while the other enclosed with the black tape is an active one. Passive, active.
Passive, active.
Okay. The difference between the two is that an active buzzer has a built-in oscillating source, so it will generate a sound when electrified. A passive buzzer does not have such a source, so it will not tweet if DC signals are used. Instead, you need to use square waves whose frequency is between 2K and 5K to drive it. The active buzzer is often more expensive than the passive one because of multiple built-in oscillating circuits.
There's 3 people watching.
Cool. So there's a little diagram here where we're going to plug up on our Uno board.
Okay.
So let's go ahead and see if we can power this bad boy up there.
Let's hold it for you.
We won't power it up yet. Let's see.
Okay.
So here's an example of how they're going to set it up. They're going to put... thought we were doing... Here, passive one away. See, we're gonna go 2 cables here, okay?
Okay.
Why don't you go hit the light switch real quick?
Hold on, guys. Be right back.
Okay, we're right back.
I'm right back.
Look, I'm gonna show you. See that tiny little hole there?
Yeah.
Okay.
Is one of those things going to go in there?
I wonder how you tell. Let's see. Oh, yep. Okay. So we should know the longer one. The ground, right? Why don't you go get that phone for me?
We have one of my.
Okay. Let's see here.
Ow. Do you like that? Don't listen to that.
Try to determine how we tell which is the longer one should be positive, right?
I know which one is longer. It's the one on the right. You just tell. Just tell. You just.
No, it's marked on the top. Positive. Okay. So look. Come here. Saw that tiny hole in there?
Mm-hmm.
That little pin's gonna go on the hole. Why don't you put that one on there? Get it?
Yep.
Okay.
Yippee.
So let's look at this picture. For the negative side, we're gonna put it in the ground spot. We're gonna look at here real quick. Okay. So can you see these words on the side here?
Yeah.
You see that G and D?
Yeah, that means ground.
That means ground. Okay. I'm going to show the negative side going to ground. And for us, that's going to be
Brown.
this brown wire. And you put the brown wire in that ground hole. You see the hole right here on this side. Make sure it lines up with ground.
It's lined up with ground.
Okay. And for our red wire, let's make sure we got this right. We're going to go to the one marked 12. You see 12? You want to put it straight in there. You don't want to bend that too much. Okay, it can bend, but you don't want to bend it too much. There you go. Good job. Okay, so you've got the active buzzer wired up to the board. Okay.
Okay, I want the buzzer.
This is after wiring, open the program to the code folder for this, and we'll click upload. So we're gonna power up the board real quick. Here, it's gonna come on.
Yeah.
So we got power. Let's go and find our folder. Okay. Upload this to the board here. Uploading the code now. Our orangish yellowish light will notify us when the upload is done. The computer is showing the sketch being compiled right now. Still compiling the sketch here. Turn the whole music up a little louder. Okay, we're uploading. Oh, hear that?
Yeah. Is it buzzing?
Yep, that's our buzzing.
Oh, that's annoying.
See if we can look at the code.
That's very annoying right there. What is it? Looking at our code, guys. Can you hear this annoying noise right here? This is actually buzzing. This is actually buzzing.
Okay, just set it down. Let's see. changed up the code a little bit to see what happens, not sure. It's kind of got a see what happens when we do this. Okay, so we'll take power from the board, unhook our active buzzer. Okay.
Okay.
Okay, we'll go on to the next lesson. The next lesson is passive buzzer. In this lesson, you will learn how to use the passive buzzer. The purpose of the experiment is to generate 8 different sounds, each sound lasting 0.5 seconds, from alto, do, re, mi, fa, sol, la, si, to treble do.
Come on, come.
We'll need the Elegoo Uno R3 board. That's what we got right here. We'll need the passive buzzer, which we have right here. And then we'll need these 2 cords again. So go ahead and get those 2 cords attached there, please, sir.
Okay, I'll attach the ground one here. And if you want to do this at home yourself, it's easy. But if you have this kit in your phone.
We are master electricians, right?
Right.
That's right. Okay. Okay. So we've got those set up. Don't touch anything. Let's see. Passive buzzer. The working principle of passive buzzer is using PWM generating audio to make the air to vibrate. Appropriately changed as long as the vibration frequency, it can generate different sounds. For example, sending a pulse of 523 hertz, it can generate alto do. Pulse of 587 hertz, it can generate mid-range re. Pulse of 659 hertz, it can produce mid-range mi. By the buzzer, you can play a song. We should be careful not to use the Uno R3 board analog write function to generate a pulse to the buzzer, because the pulse output of analog write is fixed at 500 hertz. Okay?
Okay, we need to be very careful with this.
You didn't even understand what I just said, but okay. So,
I'll connect the brown one where it's supposed to be.
stop. What are you doing? You put the ground in the ground? Okay,
Yeah.
be careful. The red one is going to 8. Not 12, 8.
8.
You need to work on putting them straight down in there, okay?
Okay.
You don't damage those holders there if you do it the wrong way.
My hands are not steady all the time.
It's okay. So we've got it wired up. We'll get some power to the board here.
Be careful.
The board is on. We don't have a program loaded for this buzzer yet, so that last buzzer was wired up differently and programmed differently. I'm curious what would happen if we do that. Let's not mess around with that. Let's see.
Well, look what this looks like. So connect up, everybody. Get everything plugged in.
Be careful, it's got power, man.
Ah! Be very careful with the active one. This guy.
We gotta check our libraries real quick to make sure we have the pitches library uploaded. Is that horrible, man?
No. Oh, here it is. Yay.
Tools.
As I put it. Just getting a drink, everybody.
Okay, so if we can run this, make sure you have installed Pitches Library and install this electrical work goes. It's already got that line there. So we're good. That should be good. Let's see what happens. See what happens. Compiling a sketch. So we should get a do, re, mi, fa, so. Did they give us all notes?
I just got a drink, guys. It's okay, I'm still here.
Do-de-do.
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 Do-do-do-do-do. Oh, dum-de-dum-de-dum.
Watch out, man.
Woo! What are they gonna... Oh, I'm finished loading. That is that right there. Oh,
It's pretty cool, dude.
yeah. I Oh my goodness. After a while, that would probably get that too much annoying. Ugh. But it's still very cool.
Very cool. Lesson 8, Tilt Ball Switch.
What?
In this lesson, you will learn how to use a tilt ball switch in order to detect small angle of inclination. We'll need the Elegoo Uno R3. We'll need 1, tilt ball switch, and we'll need 2 female to male wires. Is this our tilt ball switch?
I think so. Has the picture.
Put this in there.
Where'd it go?
Just put it in there somewhere. Let's make sure I have one of those.
Stop rolling everywhere, you dang ball.
Tilt switch.
Tilt switch.
Okay, so tilt sensor. Tilt sensors. That's this tilt ball switch. It's a tilt sensor. Allow you to detect orientation or inclination. They are small, inexpensive, low power, and easy to use. If used properly, they will not wear out. Their simplicity makes them popular for toys, gadgets, and appliances. Stop doing that. Sometimes they are referred to as mercury switches, tilt switches, or rolling ball sensors for obvious reasons. They're usually made up of a cavity of some sort with a conductive free mass inside, such as a blob of mercury or rolling ball. One end of the cavity has 2 conductive elements. When the sensor is oriented so that the end is downwards, the mass rolls onto the poles and shorts them, acting as a switch throw. While not as precise or flexible as a full accelerometer, tilt switches can detect motion or orientation. Another benefit is that the big ones can switch power on their own. Accelerometers, on the other hand, output digital or analog voltage that must then be analyzed using extra circuitry. So, there we go. So go ahead and put the wires on that.
Down the green, down on the right side first. Is that how it's supposed to go in?
Yeah.
It's hard.
Try to get all the way up there, okay?
Okay, I'll try. I'm trying my best. Ooh, I bent it on accident.
Oh no.
I almost got it there. It's like barely there. See if it works though. Since I accidentally bent it.
Yeah, it should be fine. It won't go all the way up because they're not big enough to go all the way up. Okay, so the ground needs to go into the ground spot.
Oh, right. Good thing I'm doing this. I'm new. Okay, that's there.
And the red one put into slot 2.
Ooh. It's in slot 2.
Slot 2. Okay, let's power up the board here. We got power to the board.
Yay!
We got our switch here. Okay, that's the switch. We'll upload. This is going to be wired up, but I don't know.
What's gonna happen?
Yeah, there's no like pieces to tell us it's tilting.
It's a screw.
Everything. Don't touch.
Just Is it just going to buzz a ton of it and then roll everywhere? I don't know. Let's see what happens. Right here, that is just doing something. I'll never leave. I'll leave to see if I need to do something. But I'll just get a drink. Or look at something for a second.
Okay, it's uploaded.
Okay.
Okay, so you see the orange light went off? Let's see what happens. Look, you see that? Watch the orange light. See, there's a ball in there, so it knows when it's rolling, right? Watch the orange light. It can sense the movement.
Whoa.
It can't sense it until I put it.
Send it. Do you see that though, guys? Whenever that ball moves, that orange light comes on.
It's pretty cool.
Yeah, without the ball moving, it's off the whole time. That's cool. So.
Alright guys, we'll be back in about 5 to 10 minutes. We need to take a quick break. table here.
We're back.
Lesson number 9, servo. Servo is a type of geared motor that can only rotate 100 degrees. It is controlled by sending electrical pushes from your Uno R3 board. Pulses, not pushes. These pulses tell the servo what position it should move to. The servo has 3 wires, of which the brown one is the ground wire and should be connected to the ground port of Uno, and the red one is the power wire and should be connected to the 5-volt port. And the orange one is the signal wire and should be connected to the digital number 9 port. Okay?
Okay.
So let's take the power from our board.
Okay.
Let's unplug these bad boys. Tilt switch. Take that off of there. So we need the board. Yeah, we will. Tapping it. Okay. We need the servo SG90. Do you know what that is? I do.
Is it?
It's this guy right here.
Oh, we haven't got to that guy yet. I wonder when we're going to be getting to the fan part. Yay,
I wonder. And then we need 3 wires. What colors do we got there? We got brown, red, and yellow.
Yep. We just need brown, red, and yellow there.
Keep it simple. We'll go.
Brown, red, and yellow.
There's yellow.
Alright.
There's red.
Alright. Look at that.
Just need to pull a brown one. We don't have any male-to-male brown ones, huh?
No. Too bad.
Too bad. We'll go green for the brown, okay?
Okay, I wonder if this will work.
It'll work just fine. They're all the same. They're just different colors. All the same, but just different colors. They're all just wires.
I'm gonna put this in here.
Nope. Not yet, okay?
Okay.
Well, let's see.
Wow. Do you see all those gears in there?
It says component introduction. The SG90, which is what you have in your hand there. It's universal for JR and FP connector. Cable length 25 centimeters. No load operating speed 0.12 seconds 60 degree, 4.8 volt, 0.10 seconds 60 degrees, 6 volt. Small torque 1.6 kilogram per centimeter. Temperature -30 to 60 degrees Celsius. Deadband width 5 US. Working voltage 3.5 to 6 volt. Dimension 1.26 inches by 1.18 inches by 0.47 inches. Weight 4.73 ounces. Okay. So let's go for the connections. You're gonna put these wires. So put the green to the brown. Start with that.
Okay.
Let me see what you just did. Okay. Don't push super hard, but that's right. Do the red one next in the middle. You don't have to push super hard, just put it in there. There you go. Yellow to yellow.
To the yellow.
Okay.
That good for the yellow? The green, the brown, and the yellow is
Yep. So put the green to the ground.
It's fine. Ground. Ground.
Okay. You got the red one goes to the 5 volt, which is over here. It says 5V. You see it there? 5V. It was up here where you, no, it was up there where you were looking.
It's there.
Let me see.
It's there.
That is correct.
Where's the other
And
one?
then yellow's gonna go
On the other
to
side.
number 9.
Number 9.
Number 9.
Pull loose 1. 2. There you go. I connected all of these wires onto this. My dad is loving me to do that, and I like it. Ta-da! I just need to upload something if we need.
Yeah, we gotta upload this code real quick.
Alright. I might take a drink while this is happening.
Let's open it up. Oh, we gotta get power to our board. Might need to be connected for this. Would be the best option.
Take my own tiny little drink. I mean brick, not drink.
Alright, dude. So, let's put this over here for now. Alright. Let's upload this code here. Compiling sketch, uploading. Let's see what happens. In the code for the descriptions for the code, it's saying it's going to go from 0 degrees to 180 degrees. They'll tell the servo to go to position, leave it there, position in variable PLS. Waits 15 milliseconds for the servo to reach the position. Goes from 180 degrees to 0 degrees. Not really a whole lot to tell us. I guess we could have.
What are those?
So, these are things we were supposed to put on there prior to connecting it, I think.
Probably in there somewhere. Oh, be careful. You are gonna.
Careful with my middle name, dude.
That's my middle name.
Alright.
This thing is in the shape of a sword right there. I guess they turned it into a sword.
Do you know where the little yellow screwdriver is?
No. Be right back, guys. Actually, I'm close, but I'm still kind of near you. It's not here.
So it is turning. It's okay, let me see what I can do here. Attach a little arm to the motor here so we can all see that it is turning. You can hear it. It's not turning now, I disconnected the power.
Ew, dang it. Oh, be careful. Careful that he's not moving still.
My middle name is Careful.
Seriously, yeah. My name is Careful.
It's Mark, I'm super careful kid.
But it is true.
All the time. It's gonna fit better the other way.
Careful wires. Here.
Got the little arm connected. Now let's give it power and watch this bad boy spin away.
Oh my.
It's gonna go 180 degrees, stop, and go back the other way 180 degrees. Stop, go back, stop, go back.
How's it turning that thing with that screw on there?
The first one looked a little less than 180, didn't it? It's the screw is just holding the arm onto the piece on the top that is turning. See all those little motors inside there turning?
Yeah. Can you see that, guys? If you look on the bottom, you might see the power thing. And the power gears as well. Yeah. The little sensor things.
Okay, so we'll take
Lesson
the power off
10.
the board.
We're learning about this, lesson 10. We're learning about these things. They look like eyes to you, but
Can you read what that says?
lesson 10. LED.
No.
It's hard to see. Oh. Lesson 10. Ultra. Ultra sensor. Ultrasonic.
What word is that?
Sonic.
Okay.
Ultrasonic sensor module. Wait. Module.
I know that one a few days ago, remember?
Yeah. And this is this guy right here.
Nope. Our output is low. I don't know what that means.
What?
So video output is low. We need the board, the module,
And that.
then we need 4 female to male wires. So we have 2 here, right?
Right. And you started it without me.
Okay. 2 more in there.
Right, so it looks like they're stuck together.
So ultrasonic sensor. Ultrasonic sensor module HCSR04, which is what we've got right here.
Yep.
Provides 2 centimeter to 400 centimeter non-contact measurement function. The ranging accuracy can reach to 3 millimeters. The module includes ultrasonic transmitters, receiver, and control circuit. The basic principle of work is using the I/O trigger for at least 10 US high-level signal. The module automatically sends 840 kilohertz and detect whether there is a pulse signal back. If the signal back through high-level time of high output I/O duration is the time from sending ultrasonic toward turning. Test distance equals the high level time times velocity of sound, all that multiplied by 340 millimeters per second, then all of that divided by 2. The time diagram is shown below. You only need to supply a short 10 US pulse to the trigger input to start the ranging, and the module will send out an 8 cycle burst of ultrasound at 40 kilohertz and raise its echo. The echo is a distance object that is pulse width and the range is proportion. You can calculate the range through the time interval between sending trigger signal and receiving echo signal.
You got the wrong.
Formula is US divided by 58 equals centimeters, or US divided by 148 equals inch, or the range equals high level time times velocity multiplied by 340 meters per second divided by 2. We suggest to use over 60 millisecond measurement cycle in order to prevent trigger signal to the echo signal. Are you okay, dude?
Yes.
Got another long enough break?
Yes.
Do you want to wire this up?
Sure.
Attach those 4 wires to that board there, please.
Where do they go?
No. Any color to anyone, it doesn't matter.
Okay, good. Alright, that's okay.
It's fine.
Okay, last one. This could be a little bit hard.
Turn it. There you go, like that. Okay.
I got all those in.
You see they're all labeled here?
Yes.
Alright, for the first one, that looks like a VCC. It's going to be your brown wire.
Alright.
That's going to go to the 5-volt one. 5V.
5V. Looks like it's gonna go on the other side. It's out of the way. You're saying red one.
Right, and look at that 5-volt. You see under there it says ground right below that one. There's a ground one there. Okay, what color do you have on the ground one here? Yellow?
Yellow.
So put yellow in that ground right below the 5-volt.
Okay.
Yep. Alright. For your red one, that's going to go into 12. And then for your last one, your orange one, that's going to go into 11.
11. Okay. Okay. It's in there.
Thank you. Okay, so power our board. Upload the code. Let's see what happens.
Is it uploading?
Something happened.
Hi, Mommy. But Mom's up here. Whatever's going on. Alright, did it upload so it might flash?
No, that's because I reset it. Something's going on here.
If you want to reset it, just push that button.
Oh, thank you, sir.
But let's see. Might have to take tiny break for the computer. Just like that.
We should like looking at my desk, you'll see in the cubby right there the group comic book or whatever. The flash drive right there. We grab that flash drive, please.
We're going to Emma's house. Mommy!
Yeah. Thank you.
Dang it. Hey guys, do you like this music? Might not see me even in that chair, but if I just see my hands, but I'm still here just talking. That's it. Be right back, guys. I'm glad to take a break, guys, for the computer. And now you have to take a break. Another break. Be right back again.
We are back here. I am working on uploading the code here for this module.
I'm back, everyone.
Edward's back, everyone.
I don't know what's going on with this computer. What do you think what's going on with this computer, guys? Can't be broken. I'd never be broken, eh? It's probably just weird.
Who would? No one even said it was broken, dude.
I know. But I said.
Compiling, it seems to make it a little further than this time. Don't ultrasonic me, dude.
What? I haven't seen anything. What?
Okay, Edward took a break. Okay, his break looks to be done. He's coming back.
We have to take a break, guys. Whoa. My cushions fell. Woo.
What's this supposed to say?
Bye.
What's wrong? Okay, it's uploaded.
Okay. Finally, it's uploaded.
What are we supposed to do?
Almost.
Yeah.
Alright. We're taking a break. Hello. Whoever's in there. What?
Edward.
Yeah.
Look. Oh, dude, look. Oh, dude, look.
What?
You see these numbers filling in here? Okay, it's sending this signal, right?
Whoa. Whoa.
It's showing, okay, the signal. My hand is 11 centimeters, 13 centimeters over the top of that sensor. That's wicked. See, show the screen. You got a monitor running up, and it's based off the ultrasonic signal. It's giving the distance what's above the sensor. Edward, put your hand over the sensor. Go up a little further, so we can keep it showing. See the numbers changing? Go up some more. It's pretty neat.
That is cool.
I was showing the phone is like. Let's see.
Alright, we're gonna control the speed. Shit. So, hey. But get this part looks fun. So we're gonna control the meters. Let's go. What?
Put that up. That's not what we're doing. Okay.
What happens to every light? It is dark. Where does the lights go? Where the lights go? The lights. Oh, my hands and my eyes just hurt. I'll just go away.
So we'll take the power from the board here. And plug our wires from our sensor. Box. The next tutorial is going to be the DHT11 temperature and humidity sensor. In this tutorial we will learn how to use a DHT11 temperature and humidity sensor. It's accurate enough for most projects that need to keep track of humidity and temperature readings. Again, we will be using libraries specifically designed for these sensors that will make our code short and easy to write. We got the board. We need 3 of those wires there. Even though they're showing 4 prongs.
The thing. We need.
Okay. So then we gotta find that little sensor.
It's right here somewhere. No, it's in the box. No, it's in here. No, it's in the gum. See, here it is.
Okay, so if you look at this diagram on it, look here. We're gonna know 1 is the VCC, 2 is data. This picture's showing 4 is ground, but that's gonna be 3 is ground for us, okay?
Okay.
So
That's good. Done.
The DHT11 digital temperature and humidity sensor is a composite sensor which contains a calibrated digital signal output of the temperature and humidity. The dedicated digital modules collection technology and the temperature and humidity sensing technology are applied to ensure that the product has high reliability and excellent long-term stability. The sensor includes a resistive sense of wet components and an NTC temperature measurement devices. It connects with a high-performance 8-bit microcontroller. Applications: HVAC, dehumidifier, testing and inspection equipment, consumer goods, automotive, automatic control, data loggers, weather stations, home appliances, humidity regulator, medical and other humidity measurement and control. Product parameters: relative humidity, resolution 168-bit, repeatability plus or minus 1%, RH, accuracy at 25 degrees Celsius plus or minus 5 degrees RH. Interchangeability: fully interchangeable. Response time. A whole bunch of more data there. C. Pin description. The VDD power supply is 3 volts to 5.5 volts. The data serial signal is a single bus. The ground is the negative power. So let's see where they want us to connect. Okay, so let's connect a wire for the ground. Which one's ground? 1, 2, or 3? It's not going to be on the picture. What did I tell you?
That the ground should be ground.
Nope. Which one on here is ground?
Number 3.
Number 3?
Yep.
So connect number 3 to the ground for the ground.
It's connected.
Okay, and that's going to go in the ground spot that's next to the 5-volt spot on the board. Nope. The ground is going to go in that ground spot by the 5-volt.
Okay.
The one in the middle, the number 2 pin, is going to be our power. Put the red one on there, and that's going to go to the 5-volt. Nope, one in the middle, dude. So you go to 5-volt.
Next to ground.
Okay, you can put the orange one on the last one, and then that's going to go to number 2.
Right. And number 2 is on the other side.
Yeah.
Hey, don't let my hair touch that. Number 2.
Number 2. Push so high, okay.
Okay.
Get power to the board. And as you see, we only need 3 connections to the sensor. It's not doing anything yet, but okay. Since one of the pin is not used, the connections are voltage, ground, and signal. So after we've wired it, we control it, we gotta upload the code, make sure we have the simple DHT library.
Yeah, that's a little bit cool.
Okay. Here.
Dad, look at this. There's that blinking light right there.
Do this here.
Punk. Oh.
Make sure we got that simple DHT library. Okay, uploading. This little blue box here is our sensor. Probably be able to open up that serial monitor on the computer again, and it'll show us what the readings are. Anyway, till we get to the lesson where we put more than one of these things together at a time using that breadboard, you know?
Yeah.
Have the ultrasonic sensor going and the humidity temperature one. And we can build a robot that goes around the house and they can tell us how hot and humid it is everywhere and how far away the ceiling is from where it's at.
Yeah.
That's what we need, right? Robot number 1, here we go.
Robot number 1. You mean MVC one? MPC?
EPC?
EPC. You mean...
We're uploading. We're sensing.
There's 2 orange
Okay,
lights
we're
on.
gonna open up the serial monitor, see what we get. It is 28 degrees Celsius. Oh, it's going up. It's counting up. It says 29, and it's about 20% humidity. It's changing every few seconds. That's cool. We'll go back to the code on the screen here.
Boop, 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 boop.
That's the readings
Boop.
it's doing every
Boop,
few seconds.
boop.
On the bottom line, it's showing us the Celsius and the humidity percentage. Very cool.
Very cool.
Very cool.
Boop, 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 boop. Who's making that noise?
Do you want to pay attention to this one?
Yes.
This one is the analog joystick module.
Yeah.
So we're going to take power off the board, quit getting our temperature and humidity readings.
We're learning about the joystick guy. This guy right here. That.
That you just broke. Thanks.
Hey, it's not broken.
Analog joysticks are a great way to add some control in your projects. In this tutorial, we will learn how to use the analog joystick module. Components required: the Elegoo Uno R3, the joystick module, and 5 of the female to male wires. We have 3 here, 4, we need 1 more here. 5, okay. Stop it. Joystick. The module is 5 pins. VCC, ground, XY, key. Note that the labels on yours may be slightly different depending on where you got the module from. Let's see here. So the modules on ours go ground, power, XY, and then I guess key. Okay. Alright, so the thumbstick is analog and should provide more accurate readings than simple directional joysticks. Use some forms of buttons or mechanical switches. Okay. The thumbstick is analog and should provide more accurate readings than simple directional joysticks. Use some forms of buttons or mechanical switches. That didn't help it make any more sense. Additionally, you can press the joystick down rather hard on mine to activate, or press to select. Is that what you just did?
Yeah.
Yeah, cool.
Like our Xbox controller.
Okay. We have to use analog Arduino pins to read the data from the XY pins, and a digital pin to read the button. The key pin is connected to ground when the joystick is pressed down and is floating otherwise. To get stable readings from the key select pin, it needs to be connected to VCC via pull-up resistor. The built-in resistors on the Arduino digital pins can be used. For a tutorial on how to activate the pull-up resistors for Arduino pins configured as inputs. Okay. Okay, so I'm gonna connect these here. You gotta connect all the last ones.
Can I do it?
I just said I was gonna do it. You did all the last ones, right?
Right.
I'm gonna let you connect it to that, okay? I'm gonna do this part. You can do that part, okay?
Okay.
Sound good?
Yeah. Ow! 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 Ouch!
Okay. So, 5 tentacled monster joystick there. Ooh. Filter stick.
No water.
Crap thing. Okay. The brown wire is going to go to your ground by the 5-volt spot.
Here's brown.
Red is going to go to the 5-volt spot.
Next to the brown.
Yeah. Okay, on that same side, we're going to use some new spots down a little lower. You see like an A0, that's going to be your orange wire. A0 will be your orange wire.
I see it.
Okay.
It's plugged in.
Yellow is going to go to A1.
A1.
And then back on the other side, you're going to put the green wire into slot 2.
That's what the happen was.
Okay. So, let's go back over here. We'll get power to the board.
Alright. I'm gonna move
Okay.
joystick.
So it says we need 5 connections to the joystick. The connections are key, Y, X, voltage, and ground. I just went backwards on that. Okay, Y and X are analog and key is digital. If you don't need the switch, then you can only use 4 pins. We went with all 5, that's fine. Code, after wiring, please open program, upload the code. Analog joysticks are basically potentiometers, so they return analog values. When the joystick is in the resting position or middle, it should return a value of about 512. The range of values goes from 0 to 224. So
It turned out really nice.
So all it's gonna do is it's gonna show you that it's working, because we'll be able to open the monitor and you'll see the values for where the stick is pointing. Okay, so leave it right there, and it said it would show 512, right?
Right.
Get this code open. But this is showing us, this is how, okay, if we had a robot and we had a joystick connected to it, we would write the code that says when the joystick's at 512, the robot's sitting still, and then when the joystick's at whatever the amount is for going forward, that means it starts moving forward, and that could translate to like how fast he's going forward. You know, the higher the number, the faster he's moving forward and stuff like that. This is all the code on how all the joysticks work, like on your Xbox controller and stuff.
Yeah.
They all got some code that does the same thing. So we're uploading now. Just chill out.
And it also, you can push shit.
Just relax. It's uploading. It's God, man.
Be right back. Everybody. Tell me when it's done uploading, please.
Okay, we're uploaded. Let's open up our serial monitor here. Okay, so we're sitting still. It's showing X is 505, Y is 486-ish. Then you can move it forward. You see these numbers changing. Different values for where the stick is pointed.
No!
Press the button. It must, okay, it's doing something, see? It's showing 0 right now. Press it again. It could be reading super fast, like press and hold it. Press and hold it. See how it's 0, 0, 0, 0, 0, 0. Let go. Now it's 1, 1, 1, 1, 1, 1. So when the button's being pressed, that equals 0. When it's not being pressed, that equals 1. That's what these codes mean, okay? And the board's being programmed to read it constantly, so every time you move the joystick, it's knowing that you're moving it or pressing that button and moving it, okay?
Okay.
It's pretty cool, huh?
Yeah. Yes. Stop. Stop. Stop, stop. Stop. I'm moving it upwards. Yeah. Hey.
Alright, we're going to take power off the board. Unplug our wires here. You see that, please? Thank you. Back in there. Do you want to start this next lesson, or you want to pause for a bit?
I want to pause for a bit.
Alright, well, we'll see everybody later. Thank you for watching.
Thank you for watching. Hold on, guys. Bye. Stop, okay?
Okay.